Okay, what is it? Thursday? No, Friday.
Friday, Jim.
Friday.
Come
It's
on, how are you
Friday.
forgetting
So
about that?
happy Friday, everybody. Just want to welcome you. Thank you for stopping by. We're just gonna have a discussion today about additive materials, right?
Hmm.
Just want to quickly introduce myself. My name is Jim Teuber. I'm the director of additive manufacturing for UPTIVE, and in our Libertyville, Illinois location.
I'm Jose Corrales, the manufacturing engineer for Additive here at our Libertyville, Illinois location. And what I mostly do here is to help optimize your design to get your parts to a result that you're expecting.
Yeah, and a lot of what I do is I'll just, as the applications and questions coming in, I'll help
Hmm.
people kind of address those, make sure we're getting you in the right path. Just a little bit about Uptiv. So we are a platform of four companies. Uh, Original company was Breathe 3D Tech, which is now Uptiv Additive. And at our Libertyville, Illinois location, we have three main additive processes: the HP MJF, Forge composite printing technology, and the Stratasys FDM technology. And then we have a injection molding facility in Centerville, Michigan, called Phoenix Prototype. And then in New York, Poughkeepsie, New York, I always like to say Poughkeepsie. That's our Stanfordville machining site. They have a high precision CNC facility
Hmm.
there. And then we also have a lot of domestic and overseas partners that we get parts for that we don't have in house, right? So that's our Go Proto company
Hmm.
that uses that we can access a lot of different partners for technologies and materials that we don't have here. So today we're just going to be talking a little bit about some of the material options that we have, and some of the how do you navigate and how do you know and understand what's the right path to take. Um, and Jose, what are some of the things that we're going to talk about today?
Yeah, so we're going to dive more into our HP MJF, which stands for multi-jet fusion process here. So what one of the main benefits that that process provides is just speed, and especially in today's world where there's a lot of innovation going on and you guys need parts really fast, this is one of the main benefits of that process. We do have quite a bit of materials here, and I like to break it down into two different categories of type of materials. We have our polymers, which include PA12, PA11, a variant of PA12, which introduces glass bead, and then our elastomers, which is our TPA and TPU. We'll go in more details of where the applications can be more beneficial from these two different types of groups. But yeah, that's where we're going to be diving into.
Yeah, we want to make sure you can really get in the weeds, right, with it,
Hmm.
and we are limited on time. We don't want to put anyone to sleep, so we're going to kind of talk about some of the use cases for the material, when you would use one or the other,
Hmm.
and then if you need to really get have a consultative conversation with us, that's when you want to reach out. You can go to our website, uptivemfg.com. We have a full form there where you can submit your files, you can add notes and questions, and then we can hop on the phone and have a meeting with you, your team. We can come on site and really walk you through and really get an
Hmm.
understanding of what your needs are. Because that's the best way, right? To sit down and have that conversation. So many of our customers, they get lost. They go onto a competitor's website. They just have a bunch of drop downs. There's so many options out there right now. So that's one value add that we have. We can sit down, understand your application, and really try to get you in the right path.
Hmm.
And then what we're excited about too is now we can take you from just that additive, maybe prototyping kind of footprint,
Hmm.
see if it's a good production opportunity, talk about all the benefits of and value that making production parts additively brings to the table. And if that's not the right option, we can look at getting you into an injection molding option
Hmm.
or all the other traditional pathways. Be that single source supplier that a lot of companies that we work with really appreciate the fact that they can take a project from end to end with one company. So that's kind of what we're bringing to the table now today.
Hmm.
So let's talk a little bit about the HP
Hmm.
this episode. Then we're going to have another one for Forge and Stratasys. But today, we want to talk about the HP multi-jet fusion.
Hmm.
We were the first ones in the Midwest to get it. I was the second person to put a deposit down. Never even saw the system, but I thought, hey, this has the potential for production additive, and that's the differentiation between the HP system and a lot of other systems
Hmm.
is has a lot of throughput. It has the ability to bring some really great performance material properties to the table, but also speed and low cost.
Mm-hmm.
And those are all the things that need to, you need to hit those marks to be able to make sure it's a good platform to make production parts on. So
Mm-hmm.
we brought those systems on. We started with one. We have 13 now under our roof here at Libertyville. So we're one of the bigger additive production
I think number
facilities.
2 in the nation, if I remember
Number two,
correctly.
yeah.
Yeah.
That's pretty cool. Pretty cool. We like that. But yeah, but what are some of the things that the HP system brings to the table
Mm-hmm.
other than some of the other processes out there?
Yeah, for sure. So definitely throughput, right? So a build consists of 1 cubic foot volume. So there's a lot of potential for what type of parts that you need. And going into the materials now for what we offer for PA12, the PA11, and the PA12 glass bead media, they have really versatile, great properties for any type of project that you need. So with the PA12, that's our more of our higher heavy like throughput material that we run here internally just because it's so versatile. It has really great heat properties. It's very rigid, so you see a lot of applications for housing as well as for fixturing that we can also help too with fixturing design here internally. But what really you see the variation between the PA12, which is the main one, versus PA11 and glass bead. uh, Glass bead is going to actually, like the name suggests, as it adds glass media into the powder based material, which is going to give you that more higher temperature resistance, as well as giving it more of a rigid feel to it. It's going to be a lot more dense just because glass media is a little bit heavier. So if you have an application that requires that needs a part that needs to be more stiff and it's going to be able to take a little bit more impact, I definitely recommend the glass bead media versus just regular PA12. And then PA11, that one there, that's going to actually give you a little bit more toughness, meaning more ductility, just because of the less carbon atom that it has from PA12. So with those, that's why I break it down to that one category there, where it's basically they very versatile, but depending on your application need, that those are going to be the main differentiators from these three materials that we offer for that polymer type.
Yeah, so that's a little bit of an overview on some of the material differences, right? And
Mm-hmm.
we'll get a little bit more in detail here in a second with those. But the underlying HP process, why is it? How does it differentiate itself from FDM? Most people understand additive by an FDM process, where it's a spool. It kind of draws each layer out,
Mm-hmm.
and that's where a lot of people understand and in their mind's eye have what 3D printing is. Now this is
Mm-hmm.
a powder bed system, so it's printing one whole layer at a time.
Mm-hmm.
So that's where you get the throughput. So say a part like this in an FDM process where it would have to draw every layer out, it might take 8 hours to print this one part, right? Because that nozzle has to touch every layer, every point on that part. Where the HP process is called an area wide application. So let's say that takes 8 hours to print. If you do another one, it takes 16 hours and etc. Right? But if in the HP process, if you have this part, let's say it takes 3 hours to print this part
Mm-hmm.
because it's all a matter of the Z height, and you can get six in that same
Plate.
height,
Mm-hmm.
it's going to take 2 hours. So you can print six parts in 2 hours versus, one part in 8 hours.
Mm-hmm.
And then that's where that throughput really comes to play.
Mm-hmm.
Um, and the parts are more isotropic because there's not as much Z weakness in FDM, because by the time that nozzle draws that whole layer out,
Mm-hmm.
that part is starting to cool already. So your layer adhesion between layers as you're building that part up isn't as strong.
Mm-hmm.
So it really brings a lot of throughput, and what it also does is for our customer base, you're not we're not printing one part at a time or just that customer's part at a time. We can put like 10 different orders in one build space, right?
Mm-hmm.
So you're spreading out that fixed cost of running a build throughout all those orders. So you can really lower that unit cost. So
Mm-hmm.
that's what when you're working with a service provider that does production, and you can really drive those costs down.
Mm-hmm.
So let's really get into the individual materials real quick. We'll just do a quick overview. So our most utilized material is our PA12
Mm-hmm.
nylon, right? So we do about 80% of the parts in that material. So Jose, quickly, what are some benefits of that specific material?
Mm-hmm. So yeah, versatility and speed. With that one there, that one's going to be really great for just if you're like looking for number one material or first option material that you need something that's going to be reliable in that sense. Definitely PA12 is going to be a great choice. With that too, what's really nice is that the material, we recycle 80% of it from the powder and basically introduce 20 fresh material in it. So sustainability wise as well, it's a very, very great choice on that end.
Yeah, and then, and so also, it has high thermal resistance, right?
Mm,
It's like, again, it's an isotropic part, so you're going to get as close to an injection molded part as possible with this process and with the nylon. Chemical resistance, right?
mm,
It's got some really great chemical resistance, but some of the limitations then, why is it good? Why is it bad? It is a little bit stiffer than some of the other options, right?
mm,
It's for a one unit cost, it might be a little bit higher because again, you're not just printing an individual part. You have some fixed costs when you're starting up the system. So if you just need one part on one bill, it might be a little bit higher unit cost than other processes. You're a little bit limited on color for the HP system. So the parts after they're printed, they come out gray.
mm.
And Henry Ford used to say, we have every color available as long as as long as it's black. So most of the parts that come are nylon 12 parts. We dye gray.
Mm.
I mean dye black. Oops. Yeah. So those are basically your two color options. We've tried to dye them. It just doesn't
Mhm.
come out good because you're going from that base gray to black.
Mhm.
So some applications we're seeing with that material, it's such a kind of a catch-all. It's kind of our general purpose material. So we're
Mhm.
seeing it go from a lot of prototyping across the spectrum of industries, but we also are seeing it being utilized in production scenarios. So
Mhm.
when we can help customers design, higher functionality, say it's three parts that,
Mhm.
like this part was printed as one unit. So this is kind of a simple or demonstration of an assembly, right? Say if you in your part, you normally would manufacture it in five different pieces, have to get five different injection molds
Totally,
made.
yeah.
Now we can morph that into one printable part, and like I said, this was printed like this, and so you have those tolerancing between the individual pieces,
Mhm.
and you can have fully functional assemblies in this process. So
Mhm.
so that's the PA12. Now we also have a PA12 glass bead material.
Mhm.
Now how does that differentiate from the PA12?
Yeah, so the glass media is going to give it the better heat resistance, and this is one that we see popular a lot for more fixturing, just because it's going to be a lot more rigid. It also prints out in gray, so like Jim mentioned about how the coloring, you do have that limitation there. We do dye black, and it's a nice finish to have. But yeah, that's the main differentiator between the PA12 and glass bead. It's a little bit more costly just due to the glass media that's being introduced, but definitely if you need something that's going to be a little bit more stronger and rigid and have higher heat resistance, definitely that's going to be the choice that you would want to choose versus just the regular PA12 material.
And it also does have a little bit better dimensional stability,
Mm,
and it is stiffer, right? Some of the downsides of glass bead is it weighs more. It's heavier than the
mm,
PA12. So a lot of people, their intent with additive is to take mass away from a part, and they want to lightweight their application. So you have to understand the application's need. If that's your main goal, this might not be the greatest material option for it.
mm,
It's a little, like I said, it's stiffer, so it doesn't have as much elongation at break. So
mm,
it's gonna break before it bends,
mm,
more so than the PA12. So that's kind of, you have to understand what the what forces are going to be applied to your part, what's the application, and then
mm,
we have those options. So now another option and kind of close in that family is our PA11 material,
mm,
right? So
mm,
so what is what how does that differentiate from the A12?
for
Why would
sure.
you choose that option?
Well, number one, that really catches my interest with that material is just that it's environmentally friendly. It's based off, it's derived by castor oil, whereas PA12 isn't. So with that, there's, if you're looking to lower your carbon footprint, definitely PA11 is going to be the better option to choose from. But then as for mechanically advantage, PA11 has one less carbon atom, so it has the better ductility. And if you look at, for me, I love looking at stress strain curves. I'm an engineer, so if you're familiar with those, it's just kind of like a linear, you call that the elongation right there, and then it starts to do a little curve, and then boom, it snaps and break. You're going to see PA11 has that a little bit more of a stretch compared to our PA12. So if you're looking for something that's going to give you a little bit more, alert before it actually breaks and fail, PA11 is going to be that main advantage for that.
Yeah, and a lot of, like Jose was saying, there's a lot of conversation around eco-friendly. How do we work better with our world, right? Our environment. Claudia, that's behind the camera right now, smiling because that's a passion of hers, right? So this is a great option. It's 100% biodegradable material. Jose was saying it's derived out of castor oil, but it's a great product. We're seeing a lot of it in the automotive industry. A lot of automotive companies are wanting to move to a more sustainable footprint. So they're looking at this as a solution for some of their needs, right? Great for duct work and different things, interior features in a car. So we're seeing some of those applications for that material. So excuse me. All right, so polypropylene, right? That's one of the materials we use here. And so what are some of the benefits of polypropylene?
Yeah, so polypropylene, that's a very popular material, especially like when you go into injection molding, if that's where you're more familiar at. That's a very, very popular material that's mostly utilized in that industry. HP actually was able to create their own polypropylene powder base that we do have here in-house that we can print. But it's really well known for its chemical resistivity. So if you need like for example, like any drainage pipage that you're going to have running some solution through there, it's going to that's going to be the most advantage for that material type for your application need. It is going to be a little bit more stiffer too, I would say, for PA12, but it's a really good material choice option too.
Yeah, and most of the HP materials in the process, we can make watertight and airtight components. So like polypropylene, we're seeing a lot of automotive applications where they're putting solvents or whatever in a chamber. They're prototyping for it, and they can actually use the prototypes in a real world situation. So we're seeing that again, like Jose said, very chemical resistance. We can't even dye the parts because it doesn't even absorb the dye. So that's how chemical resistant. So that material, it's great, and you better like gray because that's what you get. But and it's great for the elongation at break. So it's even better than the PA11. It's great for living hinges, snap, and fixturing and clips and things of that nature that are going to have a lot of material fatigue. It has a higher, it will last a lot longer than the fatigue rate. I don't know what the engineering term is.
Yeah, no fatigue. Yeah.
Just for that. But
lifetime cycle.
Yeah, there you go. Cycle lifetime cycle rate is higher with that material. So that's a great material for that kind of application. So let's talk real quickly about our elastomer materials.
So that one, so TPA and TPU are the two elastomer materials that we offer here. So with those that's going to be your rubbery-like material that you need to have some type of rigidity, but also too is going to be able to flex and bend without snapping or breaking. So the main difference between TPA and TPU is biocompatible. So it's very safe to have with skin contact. So we see that a lot for medical purposes. And for TPA, that's going to be really a little bit more better for your chemical resistance for outdoor applications. So very rubbery like, I would say too, a little bit more costly compared to our PA12 material as well. But with those materials, that if you need something that's going to have a little bit more durability, and as well as going to be flexible for whatever your application needs to be, definitely those are the two material choices that you're going to want to choose between. Just remember the main distinct difference between one and the other is slight mechanical property difference, but really one's just TPU is bio compatible, whereas TPA isn't.
And we can take vapor smooth the TPA. So if it's
Yes.
and if you need to clean the parts
Mm-hmm.
for your application, if it's something that's gonna be exposed to some solvents or something that you need
Mm-hmm.
to clean them, that's a great choice. So
Mm-hmm.
the one of the downsides of those elastomeric materials is the TPU is 95 Shore A, TPA is 88 Shore A. So it's a little bit stiffer than some people's needs are for their applications. So the durometer is a little high. So
Mm-hmm.
how we can combat that is like this part. We can introduce a lattice structure to the part, right? So if we just made this out of solid TPU, it'd be really stiff. But
Mm-hmm.
we can make it so you can introduce a lattice structure to get closer to that durometer that you need. So great option there. Orthotics is a big, they're adopting the TPU material,
Mm-hmm.
custom orthotics. So people are going to able to make something that's custom to them, right? They're able to get a foot insert, a shoe insert, or something that is perfect for their foot.
Mm-hmm.
So this is some of the applications that we're seeing, over mold kind of applications, handles, grips, and then also soft jaws like end of arm tooling for robotics. If you want something that's non-marring, great material.
Mm-hmm.
It's got great wear resistance too.
Mm-hmm.
So the last material that I'd like to talk about is our newest material, our PA12 white.
Mm-hmm.
So it's more of a, like I showed a little bit of it here. It's a very bright white material, and we're really excited about this because, like I said, we were real limited on the color options
Mm-hmm.
we could um, offer to people with the gray base. But medical vertical is, everything's white.
Mm-hmm.
SLS, selective laser sintering, that was a material option that was really has dominated the medical industry until this product came out.
Mm-hmm.
So we're going to really start seeing a lot of demand for this because this is just a superior process.
Mm-hmm.
It's more isotropic. You can vapor smooth these parts. And what it does open the door for is dyeing into the other colors. Say you
Exactly.
have you need these parts on your assembly line. You need a red part for go no go gauges or
Mm-hmm.
whatever it is. You can get closer to the colors that you need with
Mm-hmm.
being able to dye the white
So
parts.
it's a canvas, when you typically paint, you always have that blank white canvas, so that way you can have that contrast. So
Agreed.
definitely, I feel like it's with those, since it's a new material, we'll soon get to diving into more color options versus just black right now.
Yeah, so we're
Mm-hmm.
really excited, and um, that's the material suite that we have for the HP. We could really get into the weeds with it, but you know, the way we feel that's communicated to a person, that's more individually, right?
Mm-hmm.
If we can get on the phone with you, sit across the table with you, and we can really understand and get some samples in your hands of the materials, that's when we really can make sure we're getting you on the right path,
Mm-hmm.
right? So that's the best way to really understand. But maybe with this little conversation we had today, if you get on our website, maybe you can get closer to the mark right off the bat. Just by submitting your needs through our portal, or you can always just email Jose or I. I don't know if we're putting our emails on the. Yes, you get the double thumbs up from Claudia.
Mm-hmm.
So yeah, we'll be having that on our when we send this out. But hey, we wanted to thank everyone just for showing up and clicking on. I know there's YouTube and Instagram is hard to pull your eyes away from sometimes. Some of the other content out there, but very happy that you clicked on us
Mm-hmm.
again, if you need to get in the weeds with your application and your discussions, please feel free to reach out. Um, Real quick, we just want to go over some quick questions here. How do I choose a process, process material? That's some of the questions we get asked. And again, if we know the application and knows what the needs are, the problems you're going to solve,
Mm-hmm.
we can get you closer to the mark
Mm-hmm.
right off the bat. And if you need your parts yesterday, what's the best option? we can do HP parts overnight, but if you need parts almost same day sometimes, some of our FDM options might be better. If you just need one,
Just the
if you
one-offs.
need this,
Mm-hmm.
FDM might be your best option because we
Mm-hmm.
can just start printing that individual part. This might take 2 hours to print versus having to go through the setup process. And, there's a lot of fixed costs involved with the
Mm-hmm.
HP process. Great system, but it's not as, we can have a little bit higher speed, but you need a lot of volume at speed. HP can't be beat.
Mm-hmm.
And what's our best lowest cost option? Um, Again, maybe an FDM, ABS kind of PLA, SAS,
Mm-hmm.
FDM based process. That would probably be one of our lower cost options if prices is the main driver. But again, if you need low cost, high volume or higher volume, again, HP is going to be hard to beat there
Mm-hmm.
because of the throughput and our how we can share costs. So.
Mm-hmm.
Um, and what information do I need to provide when requesting a quote? Right?
Yeah.
What do you need to see?
What makes my life easier is having a well-made PDF drawing of the part, especially to a tolerancing. I think that's one of the good leading up questions that we have is the limitations for it.
Yeah.
With HP MJF, I know we talked a lot about a lot of great things, but there are also two cons for any process that you'll go into. Some of the limitations that we see is just based with the process that we see that we know it's fast, but orientation is really very important, and not many people understand that yet with this new technology that we have here. And so that's where, like you mentioned, Jim, where having that conversation with the customer to understand on how this is going to be fit onto your end use application. Because what we see a lot that's very common is how you orientate it. Since the process it's powder, we're actually spitting also agent, the detail and infusing agent. And so when you have agents, there's a very natural phenomenon that happens, which we call capillarity, where you're going to have that meniscus effect. So at the very end of that print, where it's going to have that very top surface, you're going to have the cupping on there. And so there's ways to minimize that. And so with the drawings there that you guys provide, we can go into the details of the dimensioning where, we might have to put on a more focused lens onto it to, make a custom build for your application needs. So that way we can hit those tight tolerances. But then too, if there's because cosmetic requirements, and also it is a three-axis system. So depending on which features that are most critical, my best example is for circular features. If you need that to be a true circle, you need to have that parallel to the z-axis. If it's in the xy plane where it's going to be having the print head going into fusing those, there can be some more variance on that. But yeah.
See, now I told you we weren't going to get deep in the weeds. Jose just couldn't help himself. But no, that's all good information. And then, that's what we want. What he's saying is, we want to make sure your expectations of what your results are going to get can mirror what our capabilities are. Right? We get a lot of drawings that have 3 or 4 or 5 thousandths tolerance call outs, and hey, that's injection molding call outs, and we can't usually hit that on right off the right out of the gate with our process. So we have to make sure we have those conversations, set the right expectations, so we're all communication's king, right? If we are all on the same page, it's a much better experience for everybody. So we want to make sure, we have those conversations, make sure everyone's on the same page, and then we're off to the races, right? And then the last question before we wrap it up is just, we get a lot of drawings with injection molded materials on it, or that's what's ultimately going to be the process, and how do they identify what process material would be a good fit for to get close to what they're trying to do. Again, that's something where having that conversation, understanding that we are limited to the materials we have on HP. We don't, it's not as broad based as like the FDM process maybe, but we can usually get you close to the mark and make sure we're getting you um, parts that will perform and give you the results that you need to either prototype with or end use parts. So,
Yes.
again, Jim, thank you very much.
Jose Corrales, it was a pleasure.
And we'll see you. Hopefully, we didn't bore you to death, right? And we'll see you in episode 2 when we talk about our Mark Forged and our Stratasys processing materials.
Perfect.